Hello, everybody. It is Thursday, and obviously I am not here. I am over at Boyd. But what you guys are going to be working on is the atom and quantum practice problems. So if you haven't already, walk to the door. Looks like this. All right. Go back and look at the table, which is right next to it, and pick up the paper that is right there on the side. So if you haven't already, go pick that paper up. It says the atom and quantum practice problems, and you are looking at doing an approximate 8 problems. Now, some of them have multiple questions to them, but you're going to be doing 8 problems altogether. So number 1, make sure that your name is on it, and of course we're all going to go do that right now because I said it. When you are done with it, it will go in the box, and if you don't finish it today, it becomes homework, and I'm pretty sure you all said that as I said it as well. So greatness. So we're going to go ahead and start on a couple review things that you need to make sure that you know. So we've already talked about this equation that E is equal to H times F, and so let's label what some of these are. We know what E is. E is equal to the energy in a wave, in a proton. It's just equal to the energy, and it's going to be measured a couple ways. It can be measured in joules, or it can be measured in electron volts. And the conversion from electron volts to joules and from joules to electron volts is already on your page, and I'll write it down again. So 1 electron volt is equal to 1.60, make sure that decimal gets in there, times 10 to the negative 19th joules. So obviously there are quite a bit of quite a bit of electron volts inside of 1 joule. So there's your conversion to that. So if they ask you for it in joules, you can take your electron volts and make it in that way. If you take your joules, you can convert it back into this way, depending on which way you're going. Make sure you convert correctly. All right. So then we have H, which is Planck's constant, and that is also on your sheet. And that's going to be 6.63 times 10 to the negative 34th joule seconds. Some things that I want to note is that if you use this, you have to be in joules. Your energy has to be in joules, or your answer will be in joules, one way or the other. But if you use Planck's constant, it's going to have to be dealing with joules, and this is a constant, so it never changes. Fantastic. And last but not least is you have the frequency of the photon, of the wave, of the particle, whatever it is, and that's going to be your frequency. And this is going to be measured in, frequency. This is going to be measured in hertz. And if it doesn't give it to you in hertz, if it gives it to kilohertz or megahertz or whatever, you need to convert it into hertz. So we're going to go over some conversions here in a little bit too. So there's all those guys. So this is going to be your main equation today, but we're going to have some offshoots of it. So what I mean by offshoots is E is equal to HF. The energy is equal to Planck's constant times the frequency. But if we go back to our wave equation, the speed of light is equal to the wavelength times the frequency. And what we can do with that is that we can solve for frequency. So by solving for frequency, getting it by itself, we have to get rid of the wavelength. So we divide by wavelength, right? And so we found out that frequency is equal to the speed of light divided by the wavelength. And so what we're going to do is we're going to take this and we're going to implant it in here. So our new equation becomes E is equal to Planck's constant times the speed of light over the wavelength. And a couple of things here. Speed of light, of course, is a constant, so that's never going to change. It's 3 times 10 to the 8th meters per second. It's up there on your constants list, and it does need to be in meters, which means that your wavelength down here must be in meters. So if they give it to you in kilometers, you need to go to meters. If they give it to you in nanometers, you need to go to meters. But somehow or another, you are going to be converting over to meters. So let's do some quick conversions real quick. So some things that you're going to need to know. Number 1 megahertz is equal to 1 times 10 to the 6th hertz, or also known as 1 million hertz. Another one that you're going to be end up using is nanometer. So 1 nanometer is equal to 1 times 10 to the negative 9th meter. And I'm not going to write that in decimal form because that's way too many zeros. So you can also look these up. I've written it down that if you need to use your phones to look up some of these conversions, that's okay. You should know these off the top of your head, but that's a whole different matter. All right, so there's our small review. So let's actually get into a problem. So let's look at number 1. Glenn is a DJ at a high school radio station, WPAA, which broadcasts at a frequency of 91.7 megahertz. When the station is on air, how much energy does each emitted photon possess? A in joules and B in electron volts. So we did our first things first. You always got to read. After you read, you're going to start your guesswork. And yes, you do have to show guesswork to get complete credit on this. If you don't, then you won't get complete credit. And in that case, you're probably going to fail. So we'll start with G, our guesswork. G stands for given, and so we go back and look at our givens. And of course, what do they tell us? Well, they tell us the frequency is equal to 91.7 megahertz. And yes, that is what your radio station dial is tuning into. It's tuning into a proper frequency. So number 1, something should pop out in your head is that this is in megahertz, and that is a problem. So what we're going to do is we're going to take that and we're going to convert into hertz. And what we saw earlier is that 1 megahertz is equal to 1 million hertz. So this one's pretty easy. We just take 91.7 times 10 to the 6th meters. And easy peasy, lemon squeezy. There it is. So we have our frequency. Now the other thing that we know, but it doesn't give us into the problem, is that we still know that Planck's constant, H, is the same thing every single time. So we have 6.63 times 10 to the negative 34th joule seconds. Fantastic. So there's our givens. Our unknown in this case is they want us to find the energy, the amount of energy. So we go to our right equation, E, and it comes out, we go look at it, we're looking for one that has E, H, and F, and the equation that has E, H, and F is that the energy is equal to Planck's constant times the frequency. We don't have to change it at all, so we're just going to leave it like that. So what we're going to do is we move on to our first S, and first S is the substitute, so the energy would be equal to H, which is 6.63 times 10 to the negative 34th. And all that would be multiplied by your frequency, which in this case is 91.7 times 10 to the 6th. Oh, hertz. Why would I put meter there? Why would I put meter here? It's hertz. So I'll go back and change that real quick. Hertz. And we know that this is joules seconds. Fantastic. And then you move on to your last S, which is to solve. And so you would plug this in your handy-dandy calculator. I'm going to hit pause real quick. I'm going to plug it in mine. Greatness. So I went in and plugged it in, put it in my handy-dandy calculator. My handy-dandy calculator spits out a number of 6.07971 with an exponent of negative 26, so that is times 10 to the negative 26th. Now we need to know what units it is, and it's really important. Well, it's pretty easy because we know that the energy in this case, because we use Planck's constant, is going to be in joules. So it's in joules. So that answers A. Now that's not going to be our complete answer. What we have to do is we're going to go back and we're going to look at sig figs. So the numbers that we plugged in, let's see, 91.7 has 3 sig figs, 6.63 has 3 sig figs, so our answer can only have 3 sig figs. So we start counting from the back. 1, 2, 3. The 7 looks at the 9. The 9 is going to round it up. So our real answer for A is going to be that the energy is equal to 6.08 times 10 to the negative 26th joules. And B, it says an electron volt, so it's just going to be a slight conversion. So we know, looking up at our constants, that 1 electron volt is equal to 1.6 times 10 to the negative 19th. So we currently are in joules, and so we're going to take that and we're going to divide by our constant of 1.6 times 10 to the negative 19th. And we get a fantastic answer that tells us that B, our energy in in electron volts would be 3 sig figs again, 3.80 times 10 to the negative 7th eV. So there is number one. So it's just a bunch of guesswork. The real problems here is you got to make sure that you know your units and what units you're working with going all the way through there. So if you don't have that, you're going to be in some trouble. Mr. Theme, we're not really sure. Can you do another one? Yeah, we can do another one. We'll even do. So we start on number 2, same idea. First things first, you got to read, so we read it. Bart uses a helium neon laser to align his telescope. The laser emits red light with a wavelength of 633 nanometers. How much energy in electron volts is given off by each photon of laser light? So again, we're going to start with our givens. So G, fantastic, there it is, says that our wavelength in this case, so not our frequency, our wavelength is 633 nanometers. But again, Mr. Theme, hey look, nanometers isn't what we're supposed to be, and we need to convert that over. So we're going to convert that over. We said earlier that there are times 10 to the negative 9th, so we do 633 times 10 to the negative 9th meter. Look how easy that is. That's awesome. So we move on. Wavelength, and that's the only number they give us in the problem, but the other things that we know is we know Planck's constant. Planck's constant is H, so 6.63 times 10 to the negative 34th joules seconds. We also know the speed of light. Speed of light in this case is going to be 3.00 times 10 to the 8th meters per second. So there's our givens. We go to our unknown, and in this case our unknown is still energy. Makes it really easy. We go to the equation we're going to use, and in this case the equation we're going to use is going to be the one that has E, C, H, and wavelength, which is E is equal to C times the wavelength over, oh, that is completely wrong. We're going to erase that. Let's see, erase, draw. E is equal to H times C divided by the wavelength. And again, it's already solving for energy, so we don't have to change anything. So we're just going to go ahead and substitute in our first amount of numbers. So we have Planck's constant, 6.63 times 10 to the negative 34th, and 3.0 times 10 to the 8th meters per second. And all of that will be divided by 633 times 10 to the negative 9th meters. And this can definitely screw you up. And what I would highly suggest is, remember when you're putting this in your calculator, and you should have some calculators, is you should always put the top inside of parentheses and divided by the whole bottom inside parentheses. So I'm going to go ahead and plug this into my computer, also known as a calculator. That's really funny. And I'm going to solve real quick. So you do the same. Great. I got my answer. Are you ready? Well, I don't really care, because I'm going to go ahead and tell it to you anyways. So when you solve this guy, you get an answer in your calculator of 3.14218,009 times 10 to the negative 19th. And because it's an energy, and again we use Planck's constant, this is going to be in joules. But we can't just leave it at that. That's not what we're going to plug in. So we're going to go back and we're going to look at our sig figs. So Planck's constant had 3, speed of light had 3, and most importantly, if we look down at our wavelength, the only thing that they really gave us, this guy had 3. So 3, 3, 3, the smallest out of all those is 3, so we go back and we do 1, 2, 3. The 4 looks at the 2, it's going to round, it's going to stay the same. So we had 3.14 times 10 to the negative 19th joules. And that would be your answer in this case. Alright, so again, just more guesswork. Make sure that you are converting, make sure that you're in meters, make sure that you're in hertz, and make sure that you know what energy unit you're in. With anything else, if I did create a Twitter feed a long time ago and I never really told you guys about it, but if you have any questions, I am at Themestein, and you can text me or you can tweet me some questions there if you want to. Otherwise, good luck. If you don't finish today in class, it's homework. See you guys later.